So we have been working with sine law and cosine law, and so now we're at a point where we're going to take a look at applications of the sine law and cosine law. So today's goal is to recognize when to use SOHCAHTOA, sine law, or cosine law to solve for sides or angles in triangles. So we've got all of our formulas listed here, and when we do a test on this stuff, you'll be given these formulas, so you don't have to memorize them, but you certainly have to know when to use them. So these formulas at the top are when we have side angle side or a sandwich situation. These middle formulas here where we're finding an angle is when we're given side, side, side. And our sine law we use when we have partners given to us. So let's take a look at some examples of application questions. So in this question here, Emma flew her plane 500 kilometers due east, and then after turning 25 degrees northward, flew an additional 75 kilometers before landing at an airstrip. So when we're given directions like that, we need to remember that it's north, south, east, and west. So in our situation here, we've got Emma who's starting here, and she is flying due east. So that means she's flying in an eastern direction here. And then she's turning northward and flying a distance there. Now let's try and fill in some information here. So we'll say she's starting at point A and flying to point B. Now it says she's turning 25 degrees northward, so if she was heading in this direction and then she turned 25 degrees towards the north, that's what that would look like. We are actually, and she's flying to this point we'll call C. They're actually asking us to find how far is the airstrip. So the airstrip is where she ended up at the end. So C is the airstrip. How far is that from where she started? So we're trying to find this distance here. So that's where I'm going to put my X. Now I can fill in some information here. When she flew at the beginning, she flew 500 kilometers. I'm just going to change that, and I'll just move that 25 into here. Maybe I'll just redraw that. So this is 25 degrees in that corner there. I do know that this side is 75 kilometers because that's the distance she flew at the end before landing in an airstrip. So right now, for the triangle, I know two of the sides. I know this angle that's outside the triangle, but I can use that 25 degrees to find that angle at B in the triangle. So angle ABC, which is that angle inside the triangle, is equal to 180 minus 25. So that angle inside the triangle is actually 155 degrees. So in my triangle, I'm trying to find side B. So I'm going to use my formula from up above for side angle side, because that's what I have here, is I have side angle side, and I'm going to use this formula solving for b. So a squared plus c squared minus 2ac goes to b. And now I can substitute into that. So in the spot of b there I have x, so x squared. This is side A, and this is side C in my triangle. So this is going to be 75 squared plus 500 squared minus 2 times 75 times 500, and then it's going to be cosine of the angle, which is 155 degrees. When I've done these questions before, I haven't put those in brackets. I don't need to put the brackets around those. That's not going to change things. I'm just squaring each of those numbers. So my next line, when I square those numbers, that's going to be 5,625 plus 250,000. And then when I do this calculation on the end, I'm going to end up with plus 67,973.08. I'm just rounding that to 2 decimal places there. And then my last step, I calculate that total, and then I take the square root of that. So 323,598.08. And when I take the square root of that, I get 568.9. So to answer the question is, how far is the airstrip from Emma's starting point? Therefore, the airstrip is 568.9. These are in kilometers. So kilometers from the start. Okay, so your statement at the end can be direct, just answering the question that was asked, and that's what the answer looks like for that. Okay, let's take a look at example 2. So in example 2, 2 radar stations that are 110 kilometers apart, located at both north of them in distress. So the boat's to the north, so I'm going to draw a line down here to begin with. And those 2 boats, okay, those 2 boats, I'll call those boats A and B. Sorry, those are the 2 radar stations, pardon me. So those 2 radar stations are 110 kilometers apart from each other. There is a boat to the north here, and it's located somewhere to the north here. We'll call that C, so that's the boat. These are the radar stations. Here and here. And it gives us the angles from each of the radar stations to that boat. So the first station is at a 37-degree angle with the boat, and the second radar station is at an angle of 55 degrees with the boat. And we're trying to figure out how far is each station from the boat. So we're trying to find the length of AC, so that's like side B in the triangle. And then we're trying to find the length of BC, and that's like side A in the triangle. Okay? Now in this situation, I know 2 angles, so I'm actually going to start by finding angle C, because if I find angle C, then I'm going to have partners that I know, and I can use the sine law. So angle C is going to be 180 minus 37 minus 55. So angle C is equal to 88 degrees. So that's going to be helpful to us because that 88 is that angle there. And now I have partners. So I know the partners for C, and maybe I can start by using that to find side B here. So my sine law, when I set that up, I'm going to use the C, so sine C over C, and I'm going to use the B's, sine B over B. And then I'll plug things in. So when I plug things in, it's going to be sine 88. I just found that angle C was 88. Side C is 110. Sine B, so angle B is 55. So sine of 55 over, and I don't know what side B is. That's what I'm going to try and find. Okay, so remember with the sine law here, if I cross multiply and divide, side B is going to equal 110 times sine 55, and then we divide by sine 88. And if I do that, I'm going to end up with 90.2 kilometers for side B in the triangle. Now I have to find both sides, so now I have to do the same thing, but for side A. So I'm going to use the same sine C over C, but now I'm going to use sine A over A. So sine C over C is going to be sine 88 over 110 again. This time it's going to be sine, angle A is 37 over side A. So to figure out what side A is equal to, we have to do 110 times sine 37 divided by sine 88. And when we do that calculation, you should come up with side A is 66.2 kilometers. So our statement here that answers the question, how far is each station from the boat? Therefore, station A is, and station A is, I have to use the answer for side B. So station A is 90.2 kilometers from the boat. And station B is 66.2 kilometers from the boat. Okay, so that's our answer for that one. We're going to do example 3 right now. And then we'll save example 4 for tomorrow and tomorrow. So, an ice cream cone manufacturer makes a cone with a bottom angle of 30 degrees. The sides of the cone are 14 centimeters long. So if I draw a cone here, the 30 degrees is this bottom angle, and these are 14 centimeters up the side. And they want us to, they're saying that the manufacturer would like to pack cones in square cartons with sides that are 7 centimeters wide. Will the cones fit the cartons? So we need to figure out how wide are these cones. Will they fit a box that is 7 centimeters wide? So let's put A, B, and C on these triangle sides, or in the corners where the angles are. And that means that this is side A, This is side B, and that'll be side C at the top. So, because we're trying to figure out if the cones will fit the cartons, we need to find the width of the cones. So the width of the cones, in this situation, we have side, angle, side. We're going to try and find that third side. So we're trying to find side C, so I'm going to use the C formula. So that's the formula there. And when we plug things into this formula, C is x, so this can be x squared equals. Side A is 14 degrees, side B is 14 degrees, so it's going to be 14 times 14, and then cos, and the angle is 30. So if I do the calculations here, 14 squared is 196. And then when I multiply this back part together, so the 2 times 14 times 14 times cos 30, if I round to 4 decimal places here, I get 820. So in the end, I'm going to take the square root of 52.5180. And when I do that square root, I get 7.25 centimeters. So the cone is 7.25 centimeters wide. Therefore, the cones are too wide to fit in the cartons. Okay, so that's the answer to that one. We'll do the other one for a warm-up tomorrow. Thanks.